Hey everyone, welcome. Let's jump right into today's explainer. A massive welcome to all of our 8th grade scholars joining us. Math is so often thought of as just cold, hard numbers on a page. But today, we're going to look at it through a completely different lens. We're embarking on a journey to explore the geometry of grace, looking specifically at linear equations and how we can fluidly and honestly, elegantly convert between them. Think of today's session not just as a typical math lesson, but as a masterclass in translation and flexibility. So grab your notebooks, get ready, and let's decode the secret language of lines. To really set the stage for what we're doing mathematically, consider this beautiful metaphor. Colossians 4:6 says, "Let your conversation be always full of grace, seasoned with salt." Now, think about how you talk to the different people in your life. The way you explain a crazy story to your best friend is probably totally different from how you'd explain it to, say, your grandmother, right? You adjust your words, your tone, your delivery, depending on the situation. You adapt. Well, math is exactly the same way. A single straight line on a graph can actually be expressed in several different mathematical conversations. We can use totally different forms to express the exact same line, depending entirely on what information we want to highlight.
And that brings us to the absolutely essential big idea for this explainer. Different forms of equations tell the exact same story, just from different angles. And this is why learning this matters so much. If you know how to smoothly translate between these different forms of linear equations, you gain incredible power as a mathematician. You'll be able to solve complex problems faster, you'll be able to graph lines almost instantly, and you'll interpret the real-world meaning behind the numbers with total ease. Each equation form comes with its own unique superpower, and today, you're going to learn how to harness every single one of them.
Okay, so let's break down your mathematical toolkit. We basically have 3 distinct conversational styles. First up, we've got the slope-intercept form, y equals mx plus b. Its superpower, it is hands down the easiest form for graphing because it literally hands you your starting point and your direction on the silver platter. Next, we have the point slope form, y minus y1 equals m times the quantity x minus x1. This one is your builder. It's absolutely brilliant for constructing a line from scratch when all you have is just one random point and a slope. And finally, the standard form, ax plus by equals c. This one keeps both variables neat beyond one side and is fantastic for quickly finding your x and y intercepts. So 3 different forms, 3 distinct strengths, but they can all represent the exact same line. Section 1. Master the conversions, translating between forms. Let's dive into example 1. Say you're handed an equation in standard form, 3x plus 2y equals 6. But let's say you need to graph it quickly. You'll definitely want that in slope-intercept form, right? So we just solve for y. Step 1, we've got to move that x term. We subtract 3x from both sides, leaving us with 2y equals negative 3x plus 6. We're almost there, but y still has a coefficient of 2. So for step 2, we simply divide absolutely everything by 2. The result, y equals negative 1.5x plus 3. Boom. In just 2 simple, logical steps, we've completely translated the equation, and now we know exactly where it crosses the y-axis and exactly what its slope is. Moving right along to example 2, let's see just how incredibly straightforward the point-slope form really is. Imagine you're building a house, and you're handed a set of coordinates and an angle. In this case, our slope is 4, and our point is 2, 5. To build this line's equation, we don't need to do any heavy algebraic lifting at all. We just drop our numbers right into the template. We take y minus our y-coordinate, which is 5, and set it equal to our slope, 4, times x minus our x-coordinate, which is 2. So we get y minus 5 equals 4 times the quantity x minus 2. And that's it. You've successfully built the equation of the line right there on the spot. Now for example 3. Let's see how we can take a slope-intercept equation and translate it backward into standard form. Remember, standard form loves whole numbers, and it loves having x and y on the exact same side. So we start with y equals 1/2 x minus 3. First things first, let's clear out that fraction. We multiply every single piece of both sides by 2. That immediately gives us 2y equals x minus 6. Already looks much cleaner, right? Now we just rearrange our pieces to get x and y together. If we subtract x from both sides, we get negative x plus 2y equals negative 6. Or if you happen to prefer your starting x to be positive, just flip all the signs. That gives you x minus 2y equals 6. See? You are in total control of the equation.
Section 2. Time to practice. Test your translation skills.
All right, 8th graders, now it's your turn. It's time to pause for a second and dive into these first 3 practice problems. These are specifically designed to challenge you to apply the exact step-by-step conversions we just mastered together. For number 1, you'll need to move that x term over to join the y. For number 2, think back to our builder template, which form lets you just drop a point and a slope right in. And for number 3, your task is to solve for y to isolate it completely. I really want you to approach these not as chores, but as puzzles just waiting for you to unlock them with your new skills.
And you can wrap up your practice with these final 2 questions. These will really solidify your ability to recognize and dissect the different forms. Number 4 asks you to pull the crucial data right out of a slope-intercept equation. Super fast, super easy. But number 5, that's a great conceptual check. Does that equation match the precise structure of the point-slope template we discussed earlier? Engaging with these questions is going to cement these mathematical languages in your mind permanently.
Section 3, Education with Morality, the HeroesMart Academy Philosophy.
Now, I want to shift gears for a minute and ask you a pretty profound question. I really want you to think about this. What is the actual point of being incredibly smart, passing all your tests, and being supposedly educated if you just continue to make bad choices that end up hurting yourself and the people around you? It's a sobering thought, isn't it? Being able to calculate the slope of a line is a fantastic skill, no doubt. But if your life is heading in a downward, negative trajectory because of poor character choices, well, that academic intelligence isn't truly serving you at all.
Because here's the thing, education without morality will ultimately hurt. It's literally like handing someone the keys to a ridiculously powerful sports car, but taking out the steering wheel and the brakes. All that power desperately needs direction. And this is exactly why biblical morality must be intertwined with your learning. Your algebraic knowledge, your ability to adapt and translate these complex forms, they must be paired with a strong moral framework. When you successfully blend a sharp, educated mind with a compassionate, morally grounded heart, you become a force for incredible good in the world. We're going to wrap up today's explainer with this powerful promise from Romans 8:6-7. It promises true peace of mind to everyone who keeps their mind spiritual. And honestly, that is the ultimate goal. As you engage with all this content, honoring your spiritual and moral growth is just as vital as your academic success. It's what gives you clarity and peace as you navigate all the complexities of life. So, as you head out to solve your equations today, I want to leave you with this. Are you just solving for X and Y, or are you actually solving for the kind of person you are becoming? Keep adapting gracefully, and we'll catch you in the next explainer.